Okay, so morning once again. So for this week, quarter three, week three, we'll start doing or working with circuits. So for circuits, we really need to do the real demonstrations. Okay, so all of you, modular, digitized or printed, and online will come here in school. This video will be recorded so that all learners will view the recordings and will practice this here in school. I know you don't have the resources at home, okay, but you really need to do and work with circuits next. Okay, so we'll start with identifying what we have here in school and what you're going to use during your performance task. So what I have here two types of multimeter. Okay, so I have here an analog multimeter. Okay, what is an analog multimeter? An analog multimeter from the word analog. Okay, so you're going to read it, okay, based on the readings shown on the scale. Okay, so you really need to be precise. So for now, there will be some errors in the readings since okay, there's a parallax on your end, on my camera, between the camera and the screen. Okay, so and on your end also. Okay, and by the way, please pin the video that I'm sharing on your Zoom room. Okay, so on your Zoom room, please pin, okay, my account that shows the video. Never mind the one that has an audio. Okay, just pin, okay, the one that has a video so that you have a full view of this video recording. Okay, so this is an analog, okay, multimeter. Okay, next is a digital multimeter. Okay, so most of the time for all of our experiments, we will use this one. This is more precise and more accurate than what we have previously in analog. But of course, you need to know how to read analog multimeter. So what are the variables that you're going to read? Okay, so we'll start with how to read voltage, how to read the current, how to read resistance from a given resistor, how to read capacitance from a given capacitor. So our lesson today is all about dielectrics and capacitors. Okay, and next week we will have to reconfigure series and parallel capacitors. For week 5, we will do resistors in parallel and series. Then for week 6, 7, 8, we will have combined circuits and mostly performance tasks for microelectronics. So now you know already what are the multimeter. Next, I will show you different components. Okay, so I'll just take this away. Okay. Next, we'll have a battery. Okay, so I think you know already what is a battery. So luckily for you guys, I will not require you to purchase a battery. Okay, be thankful that okay, we have a lot of funds from Robotics Club. Okay, before we have a donor, so donated I think $100. So a teacher from the US donated $100 for our components for the contest because we won several categories. So we received that amount, not from the contest, but a donation. So all of the batteries that I have here are all rechargeable. Okay, so if you purchase this, it will cost you around 500 per set. Okay, two batteries and one charger. So I will not show you the charger. And you will always see on the rechargeable batteries, its capacity. Okay, just like your battery on your phone, there's a capacity, how much it stores. This is mAh. Okay, usually it's 2,800 mAh. So meaning M stands for milli, A stands for ampere, and R is H. Okay, so milliampere hour. Ampere or the unit for current is how much electricity is flowing. It's in milli, so very small value. Then H is in R. So how much this The greater the value of your mAh, it means your battery will discharge, okay, at a longer time. But you will also charge it for a longer amount of time. That's why in your phones you have your fast chargers. So usually, what are the mAh of your mobile phones? Who has a greater mAh here?
5,000, sir.
Okay, so what unit was that, Sylvia, for 5,000?
Um, Redmi, sir.
Redmi. So
Xiaomi.
usually, okay, usually mga nano, because it has already, I think, mga quad core or octa core na. So it has
Wa
at least
Octa, sir.
octa. So it has at least 2 batteries. So you can just equate your battery, your mobile phones, kung 5,000. Usually 4,000 man ang uban. I guess ang uban greater than 5,000. Okay? So it equates to 2 batteries. Okay? So usually before, mga 2,000, 3,000 mAh lang. Then it evolves into 4, 5. Okay? And now 6, and especially for high-end phones, okay, it will reach up to 8 maybe, 8,000. Okay, so this is a battery. Okay, so just skip this first. Next, we have a component here. This is known as solderless breadboard. Okay, from the word breadboard. Okay. Anong itaw siyang breadboard? Mura siyang supas na ibusot-busdot. Okay, bread. So, I will not also ask you to purchase this one because I already purchased several of these, and some students donated, okay, especially from robotics club and other members, okay, and other STEM learners before, they donated their breadboards, okay, for the next generation. So be thankful with those students na ilang donate lang copies. So this is a breadboard where you will plug all your devices here, okay, okay, for microelectronics. So we'll use this soon. Maybe we'll have a performance task for this and a separate lesson for this, okay. So how does it look like if all the components will be set in the breadboard? So it should look like this, okay, something like this. So I have here, let me move this up. Okay, I intentionally put a green screen para mas makita ninyo ang components. Okay, so what we have here, actually I have here an LEDs, a resistor, transistor, wires, and an inductor. Okay, so we have an inductor. We will discuss more on this later. Okay, later topics now in physics 2 quarter 4. We will discuss more on inductors. Okay, medyo nilubog akong screen. I don't know. Hold on. Okay, there. Okay, so this is an inductor. By the way, this full circuit that I have is called Joule-TIF. This Joule-TIF is the main component. Okay, if you can still remember the researcher or the inventor who invented salt lamp, okay, actually she didn't disclose what is inside her salt lamp. Okay, but of course in physics, okay, if you study physics, you will know what is the component inside that, and that's this one, nari nani. Okay, and actually we have several prototypes of salt lamp here in school, because this Joule TIF, given with a small amount of voltage, it will boost it. Okay, though it will not create another charge, but it will just collect all the charge and boost it. So yan tigumon tanan kung saan niya i-fire. That's the purpose of the Joule TIF. So bisag patay nga battery, kayang magpasiga og any device as long as you have a Joule TIF. But of course, dali po siyang ma-drain. Since this one accumulates a lot of energy, dali po niya i-drain. So, kaya niya pasigawon ang mga dagkong LED on the DIY salt lamps. Actually, we have several salt lamps here in schools. Okay, I think the rest are already dead, so I need to do more of it. Okay, so this is a Joule tip. So, inani may tabo, mugamat ang inani. Okay, but magsugod sa tagpasigag LED. Next, several components. Before, okay, naman there is just, I think wala Jasmine, no? Okay, from the previous batch of STEM learners, I required them to purchase, okay, an electronic kit. Ipapalit yun ako na sila. Okay, hold on, medyo, okay. Okay, hold on lang ha. There. So what's the component of that electronic kit na ipapalit sa ilaha? I require them to purchase this one. Okay, battery holder. This is around 9 pesos. Okay, but take note, I will not ask you to buy this one. So you have this. Barato raman nun sila. A set of resistors. Okay, a resistor may cost you 50 cents. Okay, to 2 pesos each. Okay, so you will purchase several resistors. So, ano yung mga resistors ni? Nagkawakat-wakat lang. Okay, so I will just arrange this later. Okay, so I will need to move it closer to you. These are how resistor looks. Okay, so these are resistors. Okay, next. So resistors na. Next, I think you're familiar with this. Ano, not the green one. I'll just pull the color, contrasting color na lang. I have, mas favorite mo ako ng green na LED. Okay, these are, okay,
Light emitting diodes.
okay, LEDs or light emitting diodes. Dili pa ito magpasiga karon na, dili pa, not this lesson. So these are light emitting diodes. Okay, tapin na to na. So what you have in your mobile phones, your mobile phone screen is LED. Okay, composed of millions of LEDs, millions of these. Okay. Next, basic components lang sa ata. Gusto ko mapakita ng mga complicated components sa inyo. Okay, I have here capacitors. Okay, this is non-polar capacitor. Okay, so muna itong lesson karon, capacitor. So you will see if it's a capacitor, yung mura siyang battery gamay. Okay, na ay pins. Okay, this is a non-polar capacitor. I will show you another capacitor which is polar. Hold on, asa na may mga polar? Actually, all of my capacitors are broken at the eye. So mostly I have here non-polar capacitors. I will just purchase later this afternoon siguro for next week's class another capacitor. So may bala niyo pag non-polar, if it looks like this kani, naa siya longer leg. Okay, naay legs na sila. The longer side is always positive. Okay, so kaning nana ko karon ay non-polar, so pwede siya bali-balihon. Okay, pag na may mapandayan nga longer leg than the other one, that's a positive. So di siya pwedeng mabali. Okay? By the way, I will review the battery. You know already the parts of the battery, right? Okay, so wait lang sa ako. So i-focus ang akong camera. Okay. Okay, so let me go back to the battery. Okay. Akong camera man good mo, refocus siya. So I think you know already man pud asa ang positive and negative terminal of your battery. Okay, so this is a dry cell actually, but commonly we call this a battery. But the battery is defined differently. This is what we call a dry cell, okay, not a wet cell. Ang wet cell kato nasa mga truck. Okay, so we have the positive terminal or the male end and the female end. Before magod na siya marag bangal diya, so tawag lang female end, male end. But for now, it's just flat. Okay, so to be more polite and okay, dili siya kayo kuan basis, we call this a male female part before, now just a terminal, positive negative terminal. Okay, so klaro na. And take note, dapat rechargeable battery ito gamiton pag i-charge. Okay, what you have here, siguro sa inyong life, if you have batteries non-rechargeable na, do not attempt to charge it. Okay, I will just debunk some misconception of the batteries. Naiuban nga ilang ibundak-bundak ilang battery para mo charge daw. Ang dead batteries, yung ibundak, i-roll, painiton, bulot init. Okay, it will not work that way because the battery was charged with the flowing charge. That's what we discussed a while ago. Okay, so if you can charge it, it should be rechargeable. Okay, so do not charge those non-rechargeable batteries. Dili po siya mo accept of flow of charge. It will just explode ang buto mo sa inyo. Okay, so since we know already the several components, I have here complicated components of code. Okay, so I will just introduce some of the complicated components. I have here some buzzers. Gagmay kaning buzzers na ako. We have here kaning important na lang, kaning appreciate na to later. Okay, I have here an LDR. Okay. Not the LDR that you know of. Okay, dili itong long distance relationship ha. Okay, may move this closer para mas makita ninyo. Dili ni katong long distance relationship ha. LDR means physics that's okay, light dependent resistor. So if we have here the resistor, okay, that blocks the flow of charge, this one is light dependent. So where you can find LDR in your phone. Okay. Have you observed in your mobile phone, if you, especially if it's an Android or smartphone, if you call, okay, if you're in call, if you place your phone near to your face or ears, what will happen to the screen?
Mo black, sir?
Okay, mo time off no ang screen.
Oo. Pag ano po, sir, kanang, I don't know, sir, ha, sa ubang phones, pero ako ang phone, like, kanang, mo-open ko, pag mo-open ko niya, sir, dayon, ay mo type ko sa password din, matabunan ako ang camera, sir, or ang any screen, sir, kay, kanang, mo itom siya, mawala tong akong gitype na password
Okay, because okay,
sa light dependent
it's not
resistor,
yeah,
siguro, sir.
that's because of the light dependent resistor. So it if you block the amount of light passing through that sensor near your camera, so very small lang na siyang LDR. Okay, light dependent resistor near your camera, na gamay mo pula diha. Okay, so sometimes wala siya color. Okay, so if you block the light, then you may increase the resistance, pwede niyo i-turn off ang inyong screen. That's the main purpose of that LDR. Next, another one is an IC, an integrated circuit. Oh my God, wait lang. Hold on for a while. Ako sa i-fix ni kanina nabali nga. This is not a mini monster. O base mo kayo mga mini bot. This is not a robot, but rather this is an integrated circuit. Nabali ra. Hold on ha. I'll try to fix this. Okay. Sayang po. Mahal ba ani? Okay, nakabali ani. So this is an IC or an integrated circuit. Okay, you can find this in your mobile phones also. So all ICs have pins depending on the type of IC, how many pin it has, and this one works same as your brain. So we call that integrated circuit. So this IC is composed of several components of resistor, capacitors, transistors, mostly. Okay, so since I mentioned transistors, sa ba akong transistor? This one is a transistor. Okay, this one kani mo ni brain sa tanan. So diri na nukad tanang electronic devices because the transistor works as a logic gate. So siya mo control logic. So okay, so mo na brain of the computer na devices. So far, those are just precursors of our lesson. Now I will try to demonstrate what you're going to use and perform during the performance task here in school. And this works for all modalities, regardless of your modality. Okay, hindi mo kapasar physics 2 if you will not come here in school and perform this. So you cannot say, sir, I'm online learner eh. So I can't come to school eh. So what about your card? We're not able to come here in school to get your card. So I hope you can, because this is a hands-on activity. So I will start with so I will dedicate this class for discussions on how to utilize your devices. It's up to you to read your module, okay, for computations, okay? So we will do later the continuation after I discuss everything. Okay, so what I have here, the two types of multimeter. So I have here the digital one and the analog one. Okay, what I have also here is a battery. Okay, okay, this is a battery. So first, most of the AA batteries, the voltage of most of the AA batteries, if it's fully charged or if it's brand new, it's 1.5 volts. Okay, 1.5 volts di siya ang AA battery. Okay, so how to use an analog multimeter for measuring the voltage of the battery. So we will start with the analog one. So sundan nato this analog. Okay, medyo sulaw-sulaw siya, no? Okay, that one. Basta later on, I will just move it. Okay, let's find an angle where you can see the measurement of the analog multimeter. Okay, so I will just focus the screen on that. Okay, yan. So we have also two ports or terminals for your multimeter. So natay mga pins. We have here the anodes, okay, or the nodes. Okay, these are pins or nodes that you will touch the electronic devices, okay, either wires, battery, whatever electronic device test. Next, we have also the terminal on the multimeter. So, saan na to ang terminal na to karon? Ang atong terminal, it should be color-coded. So, be thankful color-coded atong naa. If it's color-coded, you should know kung asa imong gibutang ang positive or negative. For now, it's color-coded. So, let's put here the positive terminal, the red one. And the negative terminal or the common or the ground is here. Okay. Then, atong lantawon kung naa ba ko'y charge. Okay. Wala ko'y charge, no? Let's double check if it's working with others. Wala. Okay, so we will see later. Lang ay sa charge. 1.5 battery. Okay. Hopefully wala pa nalobat niya ako ang analog. Now, let's use the battery. So, unsaon ni siya karon? Okay? Remember the positive terminal. The positive terminal is
Yes, me, sir.
yes.
Share screen ka, sir?
Wala ko ga-share screen ha. I'm discussing here with my camera on. So I told you a while ago na ipin ninyo ang akong video. Okay? The account nga na video, ipin ninyo na para makita ninyo. Labasin ga discuss ko ba niya, wala mo kita ang video, ganiyara mo ga view diya. So once again, this is our digital multimeter and analog multimeter. So we will work first with analog multimeter. This one. Okay. So we will do manual reading of the battery. So this is your battery with the positive terminal and negative terminal. And we will use the correct terminals on your in your analog multimeter. Okay, so we used red for the positive terminals. It's here already indicated, and black for the negative terminal. Okay, so what we do, I repeat, we can interchange the terminals, but it's pointless. We should follow the color coding. Okay, so we will put it here for stability lang. Then I will put my positive terminal on the top and negative terminal on the negative side. So nasa reading, no? Okay, so that's the reading. Okay. So to make our readings accurate, okay, para ma-accurate mo, we read it accurately, I will put my analog pointer to 10. So I want to show 10, 20, 30. So where is that? So I have here the maximum value of 10. So it's the 10. Okay, so you have 8, 6, 4, 2, 0. So our multimeter right now is pointing not 0. So I need to adjust it pa. Okay? Pero I don't have enough time to reconfigure this one. Okay, and this is not the expensive analog multimeter. This is just for testing. Okay, kung wala gyud tay laing multimeter. Okay, this will work pero the accuracy is very low. Now, since I placed it already in 10, so akong reading should be under here 0, 2, 4, 6, 8, 10. And again, for double A battery, the maximum voltage is stored, or the label for your double A, it's not on my battery since it's a rechargeable battery. Sometimes it exceeds 1.5, but most of the batteries, especially those non-rechargeable, are 1.5 volts. Okay, that's the maximum output niya, 1.5 volts. Now let me place it here and try to check where the pointer will go. So I'll put my positive terminal and negative terminal on the battery. Okay, never mind this circuit. Okay, kulay labot na siya, the IC. So I'll put it here, positive, negative, and the reading, okay, from 1 goes to 2. okay, near 2. So that's 1.6. Okay, 3 units. So this is 1. Then we have 0.2, 0.4, 0.6, 1.6. That's our reading for the analog. Okay, hope this is recorded. Okay, so that modular learners will see the video. Next, we will use now the digital multimeter. Okay, so it will be easier for you to read the voltage for digital multimeter. Okay, so again, we will use the positive terminal. Okay, we'll use the red port, okay, and the red wire. For the common or negative terminal, we'll use the black one. Okay. Next, it's off. Okay, so that's the indicator, it's off. We can just flip it up. Then it will just start, and you can go different functions. So if we are testing the voltage at home, okay, for take note, the voltage at home has a frequency of 60 hertz, so we can use this. Okay. So the voltage reading is from the touching terminal. So nag-touch na sila sa air. So nonsense na mga reading. So you'll use this if you measure the voltage of your outlet at home. This one is in DC. Okay, so voltage in DC. This is for millivolts. If the voltage is very, very small, this port here is for measuring. That unit stands for the resistance. Okay, ohm, omega, ohm, that's for resistance. Then we can also measure the hertz, okay, the frequency. We have here the current in amperes, milliamperes, and microamperes. And luckily, this digital multimeter has a thermometer sensor. So pwede po siya mag-thermometer. But this reading is incorrect because I need to use another port for the thermometer. But we will do that next quarter pa. Okay, so what I want to measure. Do I need to measure millivolts? Dili po dagay. This is 1.5 volts ang battery. So therefore, ay pakita na po positive terminal din eh. I need to measure in volts. Okay, so look first on the digital reading. It's 0. Okay, because the terminals are here. And I have here the terminals. Okay? Once I will touch the terminals together, it shows some small reading, or maybe I will touch those sides. Okay. Yes, sir. You are charged. I got that charge or negative down charge. Okay. So depends on how many ions you have in your skin. Okay. But these are incorrect readings naman. Okay. Because you are not a complete circuit. Okay. Though we are trying to complete the circuit, but this is very, very small reading. Okay. So let's wait for to reach 0 again. Then we will use again the positive terminal, the red one, for the reading. Then the black one for the negative terminal. Okay, so it's 0. I will place my positive terminal on the positive terminal of the battery and negative terminal at the back. Then you can see here, it's 1.3. So dako kay error to, 1.6 no? And take note, this battery was charged before. Okay, so nag-dissipate na yung charge. Therefore, it's just 1.3 volts. Okay, so that's how you read a battery. So I will no longer demonstrate how to read the resistance, okay, of a resistor on an analog multimeter, but rather I will only demonstrate how to read the resistance of the resistor in a given circuit nga. Okay, I will just use this. Okay, I have here a resistor. Okay. Since a resistor is non-polar, I don't need to place two sides, or don't need to identify which is positive or negative. Now, to measure the resistance of the resistor, you can measure in either sides, positive or negative, pwedeng bali-balihon. But first, I need to reconfigure these two resistance. So this is the resistor right now, okay, which I discussed a while ago. So let me test my resistance akong lawas. Oy, taasan na og resistance. That means I I resist the flow of the charge to my body. Let's connect the two terminals. Okay, so 0 yung reading. Okay, so or 0.8. So let's wait it for to reach 0. Okay, so that's already 0. Wala siya na measure. Now let's put it here. Okay. It's quite unstable kaya mo slide ang akong terminal or akong pins. I will just put it closer. Ako ituhog yun. So what I have here is 0.98 0.984 kilo ohms. Where is the kilo ohms? Kilo ohms, ano siyang kilo ohms? It's here on top. Okay, that's kilo ohms. So we will do on week 5, week 4 and week 5, the readings on kilo ohms, okay, or resistors. So we will read the resistor color. Basahon nato ng resistor color, then nato siya i-match sa reading sa resistor. Okay, this is the true value, the theoretical value na diha kanang color. The color shows the resistance. Okay, we will do that, the reading of the resistance next meeting. And this one shows the real value. Okay, let me use another resistor. Kung ako diri resistor. Okay, we'll use this more expensive resistor from the US, donated by our sponsor. Okay. So I'll place it here. By the way, ang breadboarding, kanang pagtaod po diri sa breadboard, we will discuss it soon. Okay? For now, just observe lang how to measure. That's your goal. Okay? So, by the way, ganiha di ay, we can just interchange the two terminals. Same gyapon nag-reading. Okay? 0.985. But nagyo na siya, gamay yung error lang. Pero at least, very small na yung error. Okay? Next, let's use the other resistor. Okay, this is in, lower siya gamay because this is 220 ohms. Kaning usa, kilo ohms man, so 1,000 ohms. Kani just ohms lang ni siya. Okay? So gamay-gamay siya, resistance. And this is a different resistor kay upat ang iyang bands. So we will not do this. Mupalit lang yata og resistor nga 4 bands, dili 5 bands. Okay. If papaliton ba ta mo, I will just announce soon. If I can purchase all the materials, then all you need to do is to come here and do the measurements, okay, and trials. Okay, so that's for now on reading and identifying the basic components for electronics. Okay, and I hope all the module learners will view this video.